It says in the basic differential pair amplifier of question 2, so it's still continuing with question 2. In non-ideal situation, the equivalent offset voltages due to different factors are as the following. There is an input offset voltage due to collector resistance mismatch, and that is 5 millivolts. Offset voltage due to mismatch in the transistor emitter area, which is 3 millivolts. And offset input offset voltage due to RO mismatch, which is 1 millivolt. After connecting both the base terminals to ground, what is the expected differential output voltage here? So that's a good question, actually. So for this question, we need to find the total offset voltage. Guys, I remember that I solved this question one more time, a question pretty similar to this. You can either take it like, imagine like you have these offset voltages like vectors. Imagine that this is VOS1. That's a vector, okay? And the amplitude of that vector is 5 millivolts. The amplitude of the second offset input voltage is 3 millivolts, and the amplitude of the third offset voltage is 1 millivolt. If you have 3 different vectors and you want to add up these vectors, and then you have the amplitude, and remember that, imagine that they are orthogonal to each other. So how do we do the final output voltage, outer offset voltage? So how do we do this? We will take the square root of the amplitudes. So it will be 5 to the power of 2, the first amplitude to the power of 2, second amplitude to the power of 2, and third amplitude to the power of 2. Then all in all, you will get like something like 5.92 millivolts when you do all the things like this. So this is only the amplitude offset. This is only the voltage offset. The question is asking then what is the expected differential output voltage? In this, previously we found AD to become 50, but this is in an ideal case. Now that we're working in a non-ideal case and we are experiencing some offset here, our new output voltage will become AD times the offset. So our new thing will become AD times the offset. And again, our AD, let me show it to you. Okay, one more time. So I'm going to draw the same full circle, and then I'm going to try to find the VOD one more time. But when we have offset over here. So if I draw it one more time, imagine that I will have this thing. And so here is V sig. This is what we got so far. Here is positive and negative of VO or VOD. And here we have 2 RC, and at the top we have VCC. So the question is asking to find again AD. So I can say AD will become, you can again break it in half circuit. AD will become our, what's it called? AD will become again Hawaiian dance. Why? Because you have, if you look at it in a half circuit, you have voltage, collector voltage over there and base voltage over here. While if you break it in half circuit, your emitter again will go to 0. I think it would be better if I show it in half circuit in total. Let me show it in half circuit, and no one will get confused. This is over 2, and here we have okay. If you do the AD one more time here, and that thing will become a half circuit. So AD will become the Hawaiian length, which is RC over the little RE, and all times the V offset. V offset is 5.92 millivolt. Our RC was 5K, so it is 5,000 ohm over 25 ohm times 5.92 millivolts. If you calculate it, finally you will get 1,184 millivolts, which is, if you just show it in volt, it will be like 1.2 volt in total. So that will be the output voltage with the given offset if we connect the base terminal to the ground. Something like this. And later on we have question number 4, which is the last question of ours. Any question here? Elias, go ahead, please.
So I didn't calculate the output right, but I did get the offset. So how many marks would I lose for this question?
I'm not sure. I should check out the detail. I think
I think it was worth 5 marks.
I think you'll get the half at least. Yeah, I think you'll get the half. Did you also draw any circuit for it?
No, because I already had it drawn, so I didn't want to waste time
Okay, so I
redoing
think
it.
you will get something like a half. Yeah, still good. Any more questions? We have Aiden here. So Elias, you answered the question. Aiden, go ahead, please.
So with this, we had to basically not only get the offset voltage that would be felt on one side, but we needed the total offset voltage for the differential.
Yeah, if this part wasn't given, if this wasn't given, then you wouldn't need that VO. But here, as you see, the VO, the thing is given, so you have to like calculate it.
Oh, okay, because I must have skimmed over that then, I guess.
Yeah. Oh, sorry, guys. I may have mistaken. This is not V6. This is VOS. V offset over 2. This is V offset. So let me totally show it like. Yeah.
Oh yeah, because the offset would also be given.
Yeah. So you will.
Oh gosh.
You will connect the base to the ground, and then after you connected the base to the ground, the only thing that you'll have over there is that the offset.
Okay. Also, one other quick thing I just wanted to say. So I figured out what I did wrong in my first question. I ended up doing everything right. I just divided, instead of dividing, when you're dividing beta plus 1, it would be dividing by 100. I actually somehow by accidentally divided by 10. And so it made my final calculation is why it's wrong. I'm just wondering how many marks I would lose because I only divided that by 10 by accident.
I think the final answer has only like something like one mark.
Okay, so I'll lose like 1 mark there, and I'll probably lose
if
like.
If the other steps are correct, you only lose 1 mark.
Okay, and then I'll lose probably like half my marks here just because I didn't end up doing the offset F.
Yeah.
I just found
So it's like this part is half mark, and this part is also half mark.
All right, not bad. I basically made up in the bonus, so okay.
Yeah. Okay, guys, are we good? Can we continue? We have how many people are we have here in queue? Sorry, I totally lost the people in queue. I think there's no more. So let's continue with question number 4. Okay, here we have question number 4, and literally I can see that question number 4 was the only question that may be a little tricky. The rest was all super easy compared to the things we discussed in our class. So, in the for this question, it says a 2-stage amplifier is given below. Assume that the transistor beta is infinite for DC analysis, and take this for AC analysis, 99. Also, a DC base emitter voltage is given by this. So for part A, run a DC analysis and find the DC collector voltage of Q2 and Q3. So I want to find out voltage at this point, VC2 and VC3. Collector voltage of Q2 and Q3. So let's go ahead. Remember, we are doing a DC analysis. In our DC analysis, we will still work with all the current current source and everything. But remember, I'm gonna shut this VI2 because VI2 is AC and it should be shut down in DC analysis. So let's go ahead and take a good look at it. On the top, I have what's it called? Current source, a DC current source of 2 milliampere. So I know that because the resistance here and what you can see from here and what you can see from here are equal, I will take that as 1 milliampere. So if you do a KCL at this point, you will have 1 milliampere to the left, 1 milliampere to the right. Since the beta is given by like a large value, we can always assume that I emitter is almost the same as IC. That helps us to find IC of Q1 equal to IC of Q2 equal to 1 million. So far, we're good. Now that you have your RC, let's find little RE as well. RE1 equals RE2 equals 25 millivolt over 1 milliampere, and all in all, you have 25 ohm. So good so far. Now let's take a good look at it. We need to find VC2. But what is VC2? Guys, if I write a KVL, I can say, let me not write a KVL for now. Let me just decide that so that little 1 milliampere will also follow through this line as well. Remember, due to the fact that beta is large, it means I base is 0. If I base is 0, it means at this point, if you do a KCL, you will have I base going this way. So let me do this KCL. KCL at this point, you have 1 milliampere entering the node. You have IB, and let me call this IC2. IC2 exiting it. Since IB is 0, IC2 will become the same as 1 milliampere. So that's actually not IC2, but let me call it something else, maybe I2. So I2 will also become 1 milliampere. But listen, if the question didn't say that beta is large, when we did a KCL at this point, some portion of 1 milliampere would have definitely branch out to IB, to the base of Q3. So we weren't allowed to just simply cross out IB. But here, because beta is large, I'm allowed to consider I base to be 0. Yeah, when I base is 0, it's more like they are, how to say it? They are connected, but there is no current flowing through the base of Q3. So continuing this, okay, I was trying to find the voltage of VC2. So now let me see what can I do here. I know that if I write a KVL in this loop, what do we have? If I write a KVL, I will have, changing the color, I will have negative VC2 plus 2 times that I2 minus 5 all goes to 0. Then finally, VC2, which is the voltage of collector of Q2, will become 2 times 1 milliampere minus 5 volts. So that's all like, remember, this is 2K, this is 1 milliampere. So these two times together cancel out that milli and kilo. Then finally, it's like 2 minus 5, which is minus 3, negative 3 volts. So negative 3 volts is the voltage of collector Q2. Now I need to find the voltage collector in Q3 as well. So you know that if VC2 equals -3, it means this point, because it's like connected together, this point will also become -3. If that's -3, I can say this point, which is the emitter of Q3, will become -3 minus 0.7. Because there is a negative 0.7 added to it towards the largest negative which we can observe here. So the emitter will become negative 0. It will become negative 3.7 volts. So far I can say the emitter voltage will become negative 3.7 volts. Now, let's talk about Q3. I have no clue of the current in collector or emitter of Q3. So firstly, I have to find IE3, I emitter 3. How can I find that I emitter 3? I emitter 3 is here. As you can see, there, according to Ohm law, you can say the voltage difference over the resistance will give you the IE3. So negative 3.7 minus negative 5 over 1.3 K. And if you do all the calculations, I have the final answer. It will become 1 milliampere again. So IE3 is also 1 milliampere. Again, since beta is large, you can assume that IC3 equals IE3 equals 1 milliampere. So this is all about IC3. Remember, always, when you find IC, find the little RE as well, because later on you will need it. So again, VT over that 1 milliampere, and it will also become 25 ohm. Okay, so I still haven't found the collector of Q3. Oops. Still haven't found the collector of Q3. Let's look at it. If I want to find the collector of Q3, I will need to do one more KVL. Gonna name it KVL2. And KVL2, what is the KVL2 here? It will become, for KVL2, we have negative 5 volt VCC plus 5K times the collector IC3, I mean the collector current of Q3, plus that VC3, it means the collector voltage of Q3, and then all going to 0. So if you just do all the calculations, you will have negative 5 times 5K times 1, sorry, this is plus. So this is this plus the VC3 going to 0, then your VC3 becomes 0 volts. So here is your VC3. We found VC2 and VC3. Guys, go ahead and ask your question if there is any. Later on, I will go for part B. Elias, go ahead, please.
So I got my IE3 wrong, and that led to me getting my IC3 wrong, and then my output was different. So how much will that affect my...
Half of this question.
Half of it? Okay.
Yeah, half,
and then for the gain, because my RE3 was
no,
also
listen,
wrong.
this is only part A. Half of part A you will lose.
Okay, but then for the second part, for the gain...
I know everything is related, but because you will lose your mark here, because it all started from here.
No, yeah, I understand that, but so for the next part, my RE3 was also different. So,
It was different in finding gain and then finding R in.
Yeah, but it makes a minimal difference, right, with your RE3 being wrong to the
Yeah,
gain.
because it's just 25 off.
So will I lose marks for that part or?
I should discuss with professor, but I don't think so. I think the
Okay.
only part that you will lose some mark is here, and the other values that you use in part B and C have all initiated from part A. That's where you should lose some mark.
Yeah, and then I also made a calculation error when I was calculating VC2.
Mm-hmm.
But my setup is correct. I just made a mistake when I was rushing through to finish the
Yeah,
question.
we will definitely go over. We haven't finished marking yet, but we will definitely go over each step, and you will find so you will get some mark for each step that you have
When do you think
correct.
the marking will be done?
I think will be done like in until the I don't know, maybe Monday or Tuesday, next Monday and Tuesday.
Okay, thank you.
Yo. So let's continue with part B. Guys, in part B, let me see. Okay. So we did voltage of everything. We found everything in part A. Now in part B, it says find the overall voltage gain from the differential inputs to the outputs of two-stage amplifier. So what is the thing here? Maybe I can copy this down. Give me a second. So this is part B. What happened? So this is again part B. I just copied everything down again. I knew that, remember, the only things that really mattered was that REQ1, REQ2, and REQ3 all had the same value of 25 ohm. So this really mattered here. Now, what I want to do is finding the AD actually. AD will be VO over that VN. So since I'm doing AC analysis, now this is short, and I will have VDO versus VI over 2. But let's say, because I'm taking, you see VI over 2 here, negative VI over 2 here, so you can consider it both like a connected thing. So it's like you can connect it all and then have like VI simply. You can analyze it both ways. It's absolutely fine. So let's look at it. Let's look at it this way. I want to have VO over VI, or let's say VI V in, which is VI over 2. So again, you will do some chain rule here. First chain rule is finding VO versus the V base of Q3. So I would say VO versus V base Q3. Then from V base Q3, I need to relate it to Q2. Let me take it like V base 3 over VC2, which we found previously in AC part. So V base 3 over V collector 2. And then from V collector 2 over V in. Let me name this guy V in. And then finally, from V collector 2 over V in. Good. Let's take a look at each of these voltage gains. I have VO over V base 3. Listen, I'm talking about AC, so this will be short, this will be short. This is my AC analysis. In the AC analysis, all current source or DC current source or DC voltage sources will go to zero. So they shut down. Okay, we have VO over V base 3. VO over V base 3. Guys, again, this is a common emitter. And in that common emitter, you can always apply Hawaiian lens. So in the first part, you can apply Hawaiian lens. So let's apply Hawaiian lens for it. I know that VO over V base 3, that thing, they'll become all the resistance in collector over all the resistance in.
You stop,
sharing.
Guys, wait, let me finish it.
you stop presenting.
Oh, really? Sorry. Thanks for letting me know. Yeah, here. Sorry. Let me hide it. I accidentally passed it, I think. So I need to do Hawaiian dance here. The Hawaiian dance will be the collector resistance. So 5K, I'm writing it like 5,000 over the emitter resistance. What did we have in emitter? We have that 1.3K and that little RE. So it will be like 1.3K plus 25, something like this. Or you can like write it all like on. So instead of this 1.3, I can like write it like 1,300 on plus 25 on. So that's all good for so far. Now we have V base 3 over V collector 3. Guys, I believe that you all agree that these two are connected. So the voltage versus VC3 will become only 1. And now, from VC3 to VI2, again, look at it very carefully. VC3 is the collector voltage. Or let's say that VI is the base voltage. You can see it like a Hawaiian dance one more time, because it is common emitter again. Again, this is your Hawaiian dance. But you should be very careful with this Hawaiian dance in terms of the emitters, the resistance in emitter. So what do we have in VC2? What do we have in collector of Q2? Guys, the thing you have in collector of Q2 will be 2K parallel with what you can see from here. So remember, just forget about that Q3. Whatever you have in VC2 will be 2K parallel with this little Rn, with this actually Rn. So I can say 2K parallel by Rn on the collector of Q2. Now, what do we have in the emitter resistance, like Hawaiian dance? So in emitter resistance, there is a little Re here, a little Re here, and 2 of those 25 ohm. So all in all, you will have 2 Re plus 2 times that 25 ohm. Hope that it makes sense. So remember all the.
I think you meant to write big RE.
I know, but I just replaced it with that 25 ohm. If that's also 25.
Oh, sorry.
Yeah, that's fine. Okay, and remember, I have the emitter resistance and I have collector resistance. And nothing else matters. There's the collector resistance over emitter resistance. So I'm just going to clean this word. Okay, continuing here, I need to find Rin, which is the input resistance, which you can observe from the base of Q3. So Rn, what do we have in Rn? We have, actually in emitter of Q3, there is a little Re and 1.3K. And now you should add it up together because they are series and bring it up into the base of Q3. From base of Q3. Then you will have, because you're bringing it up, you will have times it by 1 plus beta. You will have little Re3 plus that 1.3K. So little Re, you see here we will have 1 plus 99, which is 100 times 25 plus 1,300. All like you will have 325 ohm, or you can say 132.5 kilo. So that's it. You guys found everything. So for, on the top, you need to do let me do that 2K parallel by Rn, parallel by this. So you know that on the top you will times it together, on the bottom you will add them up. So going like this, I think that I have the final answer over here. You will get 19.7. Oh no, you don't get 19.7. Fortunately, I don't have this answer, but you can definitely plug in a calculator. But let's go back to finding that AD over here. So if you continue here, 5,000 over that, the rest, that 1.3K plus RE, you'll get 3.77. And and then you have 1, then you will have 19.7 for the next fraction, and then times it all together, you will get 74.35 volt over volt, and this is your voltage gain in this crazy differential pair amplifier. Now go ahead if you have any questions. That's all about part B, and we have one more part C left. Any question, guys? Aniket, go ahead.
Just have a question in the chain rule which you did.
Yeah.
Is there a specific reason how we choose the chain rule? Like specifically the second step which you choose, the
No,
VB3 upon VC2. Like how did you choose? How did
I
you go
just
about that? Because
I
I was also
wanted to
thinking of
show
doing
it
the
in
chain.
step by
I was
step.
also thinking about doing the chain rule, but then I got confused as how the chain rule will work, and then I
You
left the second
know,
because of that.
the chain rule, imagine that, for example, you have, let me clean this first. In a chain rule, you want to have the voltage over here over the voltage over here. So no matter how you correct the voltage and go ahead, you can find it. So first, I broke it like VO over VB. Then since VB and VC2 are connected, you may even not need to write it down. But I just wanted to write it for more clarity. Then I have VB3 over VC2, then from VC2 to VI2. I just took several steps to make it more clear. But this is a chain rule. As long as you're doing the correct thing, the correct method, no matter how you are going to take this chain rule.
And VB3 and VC2 are they both the same, right?
Yeah, true. That's why I wrote down 1 as
Yeah.
a
Okay.
voltage ratio.
Okay. Thank you.
You're welcome. So on, go ahead, please.
Yeah, so I just feel like the first half of the circuit, the differential pair amplifier part, is so the reason we can't use a half circuit there is because it's not symmetrical, right?
Yeah, this is not symmetrical.
Okay.
And this is not pair amplifier. You see, this part is, the left part is paired, but the right part, that pair is like current source to the, what's it called, to the left Q3.
Yeah. No,
Yeah.
it's because like I used to have circuits, so my answer's slightly different, but I just wanted to know why I couldn't use it because it's not symmetrical.
Yeah, it's not
Sounds good.
symmetrical. It'll be pretty hard to get to the correct answer when you're
Yeah.
breaking a circuit in that situation.
Sounds good. Thank you.
No. Any more questions here, guys? No one? Okay, good to go. So let's go ahead and find the last part of this question. Let me just make it a little clean, and then we will move forward. Okay, let's go ahead. I have part 3 here, actually part C, and remember that part C was the extra bonus. So you can either do it or you can just leave it. So it says design a current source to replace the current source on the top, showing the schematic, same ideal components. So the question is saying, instead of having this current source, design something else. Design another current source. So for answering to this part of question, you should definitely have I don't know that how does a current source looks like for sure. But let us go ahead and give you some insight on this question. So for this question, firstly, I know that you can have many different many different designs. It's just your design, and remember, this is just a bonus. You can have many different designs, but one of them could be this. So you could say that, okay, here I have for example, the VCC, and I'm taking my VCC to become 5 volt, and then I'm gonna work with a PNP transistors, so something like this. And remember, this is my design. Your design could be something different. And having that R here, while connecting collector and base together. So this is my design. I'm taking this as my current source, while the collector, you know that this is the mirror differential amplifier. So what you have here as a current, which was that same as the fixed current source, the DC current source which we had in the previous case, that current will be mirrored to the collector of the other Q. So imagine if this is Q1, this is Q2, I can say IC1 and IC2 will become equal. And remember, this is a case where beta is very large, then I base is almost 0. So considering this, I need to complete my design. If this is your design, you need to find the value of R, that little r, that capital R in the collector of Q1. For finding that thing, I know that the difference over the VBE will always seem to be 0.7 volts. So it means here there is a 0.7 volt. So if I want to find the voltage at this point, the voltage at this point will become 0.7 volt less than 5 volts. Guys, remember, on the top of a circuit, you're experiencing the maximum positive voltage, and the bottom of the circuit, you're experiencing the maximum negative voltage. So if you are moving from top to bottom, definitely you are decreasing, decreasing the voltage. So that's why from that 5 volt decreased by 0.7, and here I will get 4.3 volts. I know that 4.3 volt is also connected to this point, so this will also become 4.3 volt. And then for finding R using ohm log, I know that the voltage will become 4.3 minus 0, because 0 is the ground, while 2 milliampere is flowing through that resistor, that resistor given over there. So finally, you will have 4.3 volt over 2 milliampere, which is like 2.15 kilo. This is my design. You could have had many other designs, just for your current source to replace the fixed current source given in the previous example. Guys, do we have any question here? Aiden, go ahead, please.
So I actually did something very similar to this. The only thing I was a bit worrisome on is the idea of I used, instead of having 2 milliamps coming from the 5 volt, I tried to make a resistor in between the 5 volt and the current source that was bringing down. I ended up still actually getting the same R1. The only thing I'm a bit curious is, does this current source cause a voltage drop? And when it's affecting the other circuit, the differential amplifier. That was the one thing I didn't calculate here, and I was just wondering if you could go over that.
We don't need to connect this part to the previous part. That was
I know, but I mean, in terms of realism, just because I was just trying to figure that I got actually the same stuff you were getting right now in terms of the part C. It was just something extra that I'm just curious about, because wouldn't this cause, because I started at 5 volts as well, and wouldn't this cause a voltage drop at the VC that would be differently seen.
Wait. At VC. Let me see. Let me follow it.
Sorry, the current sources, wouldn't this cause a voltage drop at the I, like a V out basically at the current source? That would be
No, why? Why do you care? Why do you care about that? There's no voltage care. There's no voltage drop. You see, let me maybe copy this one more time. Imagine that. Oh, stop. Nice. Okay, imagine that you have this, okay? Now, instead of that, what's it called? That simple current source, you are replacing it by this. You are replacing it by this. So yes, now you are replacing it by this. I know that here you will have the 2 milliampere as well. Here you will have that 2 milliampere. We just found the R to be 215. So this is 215K. And that's it. So it doesn't matter what you put instead of that current source. There is still no change in finding your VC2 and VC3. VC3, let me just quickly check. Yeah, it's not related because when I was finding VC2 and here we have VC3. For finding VC3, yes, I draw a KVL from here on. So that was KVL2. For finding VC2, I went vice versa. So I started from here doing the KVL. Still, when that 2 milliampere is coming, again, there will be 1 milliampere here, 1 milliampere here, and you take it like the rest. There's no difference. Just let me know if you still don't feel comfortable with it.
Okay. Yeah, no, I was just it was just because I was just wondering if the current source added a voltage drop that changed anything, because that was the only thing I wanted to test for, and I ran out of time to test for that. But it seems like what I did was right. So okay.
Yeah, it's just a clean replacement of the previous current source with this one. And that's it, guys. We have finished all the questions. So let me know if you have any other more question, or if not, we can all leave the meeting for now, and I will begin with the office hour at 11:15. Sharia, go ahead, please.
I know it's early, but I thought I'd ask anyway. Would you be holding like a review session or anything before the final exam? It's just that, yeah, I feel like it'll help a lot if it's like even 2 sessions, because the way you explained it, it helps a lot to understand the material.
I will let the professor know, okay? And because he always gives me the problem set and everything, so I'm just solving it for you. And I will let you know as soon as he gave me a good problem set for the review, final review. Yeah, but I think it's a good idea. I think we need it.
All right, thanks.
You're welcome. Aiden, go ahead again.
Just for my own sake, what was each question out of again? Because I kind of forgot. Do you know? Or...
I know, but I should check it out. I don't have it here. I should check it out. I am not sure.
Okay. I was just curious. Like, is there going to be one of those things where, like, if you?
I think you can still have it on Canvas and look at Canvas to find it out.
Okay.
Do you still have?
Sorry.
Yeah. Do you still have access to see the questions in the Canvas?
I can check that in a moment. Actually, the one other thing I just wanted to quickly also ask was about will there be a thing to go and review, like if we review our questions, like so now we know what we did right, what we did wrong, and based off the marks, if we wanted to just argue them at it, like saying like where did we lose marks here?
So
Will we
let's
get
see.
any
Yeah,
feedback?
you will definitely get that chance to review. But let's see, guys. Let's wait for your midterm marks. Okay. As soon as they came in, we will have a review session on the office hour time. So you will, if anyone has any question, you can guys definitely come show up and we can discuss your mark and I don't know if there is any change needed. We will definitely apply. So
Okay.
Maharan, I think you have a question.
Yeah, so I know you won't be posting the solution for the midterm, but will you be posting
Yeah,
like
I will be
questions?
posting it.
Oh,
I will
okay.
be posting. Yeah,
Okay,
no
yeah,
worries.
thank you.
You're welcome. Kishan, go ahead, please.
This is not regarding the tutorial. It was just about the marking. So
Yes.
you said you marked some of the midterms. So how was the class average? Like how's the class?
Actually, me and the other TA are doing all the marking, so I just have the forecast of the questions that I marked.
Yeah. So yeah, you
Uh,
marked. What was the average for it? Class
no,
average.
I didn't get a chance to finish that all, but it wasn't bad. It wasn't bad. At least I can say.
So out of 25, what was that? Like 19?
Like out of 25, I think like something like 17, 18. It wasn't that
Oh,
bad
okay.
that people like assume.
Okay.
Yeah.
That was good. Thank you.
You're welcome. So guys, I think that's it for now. I will definitely post it and no worries about that. Let me know if you have any more questions and if you're waiting for your midterm marks, they will come like by Monday or Tuesday. Worst case scenario, Tuesday. And that's it for now. You guys have a great day. And if you have any questions, see you in office hour. Bye for now.